Hello everyone. Today we are going to discuss the problem evaluate the expression. So it is a difficulty basic question. So given there is a number n which they give. So we need to find the value of the below expression. So it is f of n minus 1 into f of n plus 1 minus f of n into f of n, where f of n is a nth Fibonacci number. So this is what the expression is. So if you see the first example, the input is n is equals to 5. So the output is minus 1. And next also the input is 3 and the output is minus 1. So we need to use the big O of 1 and big O of 1 time and space complexities. So no loops or no extra spaces. So like that. Now if we analyze or how to solve this program. So now we will discuss how to solve this program. So here is a whiteboard. So there is a identity expression which is named perfectly for this question. So it is the expression name is Cassini identity. So if you see, so this is what the expression name is. So it is Cassini's identity. So this expression, or we can say the simply formula, so if you observe the formula, what it is, so the formula is the same thing which they gave in the question. So we will write the same thing first. So f of n minus 1 and into f of n plus 1 minus f of n whole square. So if you see, f of n into f of n, which is f of n whole square, is equals to minus 1 whole to the power of n. So you can see the expression is, which is the Cassini identity, f of n minus 1 into f of n plus 1 minus f of n square. So this square is equals to minus 1 whole to the power of n, where n is the nth Fibonacci number. So if you analyze with the one example, they gave input 1 is equals to, input 1 they gave n is equals to 5. So we saw in the question. So using this formula, if we solve, n is equals to 5 and minus 1 whole to the power of n. So how can we write this? So the whole expression simply comes to the minus 1 whole to the power of n, which is 5. So we know for minus 1 whole to the power of odd numbers, it is minus 1 only. So for any even power, it comes to 1. So 5 is an odd number, so the output is simply minus 1. So if we see another example where n is equals to 4, so obviously 4 is an even number. So minus 1 whole to the power of 4, which is again 1. So for odd numbers, it is minus 1, the output. For even numbers, the output is 1. So these are the two steps we are going to use. The main logic we are going to do. So this is the logic we are going to do. So this is the formula. The name is Cassini's identity. So now we will use this logic to solve the given problem. So let's solve. So the name is evaluate expression. So we know that if the given number modulo 2, so we know that if the given number is even, then the output is -1. So how to check if a given number is even or not? So it is simply if the remainder of the number with the 2 is 0, then it is a even number. So equal to 0, then return the output is 1. So else return -1. So we can see the sample test case is passed. So the hidden test cases are also passed. So now we will analyze the complexities. So we didn't use any extra space. So obviously the space is going to the -1. So if we compare the time or compute the time, so these two are the simple conditional statements which obviously take the big O of 1. So big O of 1 plus big O of 1 is also again a constant, which is big O of 1. So space is also big O of 1. So the complexities are matching with the given expected ones. So this question logic is easy, but knowing there is an expression which is a Cassini's identity is what we need to do. So if we know that expression is there, then we can simply write these two lines and complete this problem. So the program link is given in the description. Kindly go and practice the problem. Thank you for watching. Subscribe for more videos.